Hello and welcome to my channel. In this audio I'm going to show how to put together an R node for Reticulum which will run MeshChat on the Raspberry Pi Zero under here, and it all goes into this little box. Everything just about squeezes in. So anyway, there's a little box. You can buy these on Amazon. I think I got a pack of 4 or 5 of these quite cheap. I think it was like 2 or 3 euros each with screws, and it has a rubber gasket to make it waterproof even. So the project is going to go in there. I'm going to drill a hole in it before I go too much further so I can mount the little antenna connector. This pigtail comes with these hardware LoRa boards when you buy them usually. This one's a bit of a long cable, but never mind. Make sure you get the right size plug because there are 2 different sizes. This is the bigger one. Some of the LilyGo products have a much smaller one, so make sure you get the right one. And where do we start? Perhaps with the radio part. So this is the RAC 4631 LoRa device on its motherboard, and it's not going to focus. That's live. One thing that you do have to watch out for, apart from having the right plug to go on the LoRa antenna connector, is that it also has a connector for a USB, not USB, Bluetooth, BLE, Bluetooth Low Energy antenna. And it's good to connect an antenna there, even if you're not planning on using it, because I'm not going to be using Bluetooth. Bluetooth doesn't really work for me. Sometimes it does, and most of the time it doesn't. Very unreliable. I prefer things like this, where you plug it in and it works most of the time. But you should connect an antenna, because if you don't, it could perhaps damage the transmit section of this little module, because it'll be transmitting into an open circuit, which is never a good idea. This is not going to focus, is it? Come on. I'm not getting annoyed, I'm just short-tempered. There we go, now it's focused. So, yeah, I plugged that on there, the Bluetooth antenna that comes with one of these boards. It's from a Seed Studio Xiao board, but never mind, better than nothing. And it's a good idea, this gets in the way. So that's the radio part of the system. And then I've connected it using this very dinky little right-angle cable, which is really expensive. I think it costs about 10 euros, and it's designed for DJI drone controllers. Come on, focus. Okay. The reason I've got it is it's a very short USB cable, and it's got the right angle connectors that allows it to fit inside the box, and they're actually pointing the right way, because these you have to put them in only one way around. This USB-C can go 2 ways around, so that is quite necessary, because otherwise you end up with too many cables in the box and no room for anything else. So on the other side here is the Raspberry Pi Zero board, which is going to be running the software, the MeshChat software, and the RNS Reticulum network stack and so on, all runs on the Raspberry Pi Zero. And you don't need a monitor plugged in or a keyboard or a mouse. All you need is the USB connection, so here's the other end of that expensive little cable to go into the rack module. And I'm going to move these other things out of the way and see if the camera will perhaps focus on this. Come on, you can do it. So there's the other side, the Raspberry Pi, and also this Raspberry Pi is in a little plastic, hardly a box, it's just 2 sheets of Perspex from, I think it's Geek something. I'll try and put some links in the description. So that's quite nice to sandwich the board in there, because it protects it from short circuits and so on, and makes a nice little module. I've also, it comes with some screws and some plastic spacers, so you can screw the Raspberry Pi in between. And I found some little more spacers made from brass. These, I believe, are for mounting NVMe SSDs on small motherboards. You only need these 2 plugs plugged into the Raspberry Pi, and here are the little brass spacers, now in focus almost, which is nice to have. And it's only holding one end of the board because I ran out of spacers. For the other end, and the holes are in the wrong place anyway, as you can see, but not to worry, it just keeps the board separated, and it'll fit nicely inside this box, which I'm going to try and do now. Oh, there's no slot yet. Okay, so that goes in, will go inside there. And I'm going to file a little notch here for the cable to come out nicely. And on top of that then will go this little router, and they'll all fit inside the box because the lid stands off from here. Now the router is a TP-Link tiny little router available from Amazon at the moment. These are €20, and I use it to set up a Wi-Fi local area network so that the Raspberry Pi board can connect to it and a client device can connect to it, and that client could be a laptop running whatever operating system you want with a web browser in it to view what's happening on the Mesh Chat program. You can also use a mobile phone, and I've been experimenting with using an Android phone to connect to this, which is great. But there's one huge problem with Android at the moment, maybe somebody knows the answer. One caveat, a warning, and that is if you use an Android mobile phone to connect via Wi-Fi to this, and it talks nicely to Mesh Chat running on the Raspberry Pi Zero, that's all great. The problem is when you walk away from your home Wi-Fi network so that this little box loses the Wi-Fi connection to the internet, of course its own LAN and hotspot carries on working and devices can communicate with each other, but the problem is only on the Android phone, and it's not on a laptop running Ubuntu. The problem is that the Android phone suddenly pops up an error saying, oh, no internet connection on this Wi-Fi, and it then blocks the communication between the Android phone and this hotspot and the web page that's being served up from the Raspberry Pi Zero. So just because it senses no internet connection, it decides you shouldn't be allowed to look at other devices on your local area network, which I think is rather stupid. Hopefully somebody will be able to suggest in the comments below how to overcome that problem, because it makes it unusable when you're out in the field with no internet connection. The whole idea is that this is a self-contained unit running from a battery. So I have to take a laptop with me, and then that stays connected fine, and the laptop doesn't care that there's no internet available through this node. I don't know if it's an Android setting or whether it's the web browser I was using, because the web browser just says page could not be loaded or something silly like that, but without saying why. Anyway, I'm having a ranting day today, aren't I? Things keep going wrong, or are configured in stupid ways, I find, and they don't even let you change it, but please suggest ways of overcoming that problem if you know them. So I'll try to link all of the different devices in the description below so you can see where to buy them, and in the next part of the video I'll go and start setting things up, and the first thing to do actually will be to configure the router so that the IP addresses are all nice and everything's turned on as it should be, and DHCP's working so that this Raspberry Pi can connect to it and client devices can connect to it, and then I will program the little micro SD card so that when you put it in, this is going to be headless with no monitor connected, so you just put the card in and it should boot up. It takes quite a long time, and it should connect to the pre-programmed in Wi-Fi access point name, the SSID, and also the password, which I'll put into here in the Raspberry Pi Imager program so that everything just starts working immediately. And then of course we go to update this and install the software. So that'll be in the next part of the video. So this is the setup page in a web browser for the TP-Link router, and when you first switch it on, first time you use it, then it starts in this quick setup menu where you can go through and set up a user password and various important things, which I'm not going to do because I've already done it. Also, for you, perhaps the easiest way to start the thing, when I get back to the right place, is to use the name they give you to put in a browser URL search field, which is tplinkwifi.net. If you put that in, it should find the router and connect to it. I know that it starts at 192.168.0.1, which is the most common IP address that's used for routers, so you can put that in as well. I actually changed that later because I've got half a dozen routers running here and they all need to have a different address space, not overlapping, so I have to change it every time and make it different. Anyway, while we're looking at this page, these are some simple notes I've written. So the model number of the router is there from TP-Link. As I said, it's very cheap, low power consumption, and works surprisingly well. So you connect to the administration page, run the wizard that lets you set up basic things like setting a password, and quite importantly, you choose the right mode. I think there might be 4 different modes you can use as an access point or a client for Wi-Fi or various other modes. The one you need is WISP, which is wireless internet service provider mode, and what that does is it connects to your, let's say, your house Wi-Fi internet router, the Wi-Fi access point on that. It connects to that via Wi-Fi, and it also sets up its own access point, which is often called a hotspot, and that's on the LAN side of the router. And then it relays data in both directions from the WAN side to the LAN side. So you've got a transparent connection to the internet, but the LAN side uses a different address range because there's a NAT router inside the little router that translates to a new address space, which is quite useful for security because it means it's harder from the outside to get through that NAT router. It also has a built-in firewall. It's in fact a stateful packet inspection firewall, SPI firewall, and there's not much you can configure on it apart from passing through ports if you need to. But it does the job. I've tested it, of course, to see how well the firewall works, and it's pretty good. So I also, after I'd set these things up, I updated the firmware in the router because I'll show you the date it's got on it now is 2024. When it came out of the box, it was 2022 version. And it's always a good idea to keep router firmware up to date as much as possible because of malware problems. And as we know, Donald Trump has banned TP-Link in America for good reasons. Not that I agree with everything Donald Trump does, don't get me wrong. So, and the last thing I did was to change the IP address range. So let's go to the, I've done it again, the router control setup page here. And if we just look at the router status, because I've already made all of those changes, you have to log in with the password that you set earlier. Probably has a timeout on it if you're not looking at it. It's fairly quick user interface as well. For such a teeny-weeny router with very low power consumption, it's quite snappy. When you click around, you can see that it's quite responsive, which is nice because some of these things can be super slow, especially ones from internet service providers. Anyway, the current hardware version is 24.12.31. That's 2024 December 31. New Year's Eve. You see, they had nothing better to do on New Year's Eve than release firmware updates. As I said, when it came, it was a 22 version, so I updated it. On the LAN side, I've changed the IP address range so that was a 0 before, now it's a 1. I've got more routers that are 2, 3, and 4, so that's got its own address space. It's not being used anywhere else in this building. And the 2.4 gigahertz only Wi-Fi doesn't have 5 gigahertz, but for that price, what do you expect? And the advantage is also that it uses half the power. I do have the dual band version, 2.4 and 5 gigahertz, and that uses double the amount of power. So in this small setup that's going to run from batteries, it's an advantage not having that. It also has no VPN access point clients or servers, which you get in some of the more expensive devices, like the ones from GL iNet. They can do VPN as well, but we don't need it for this application. There's the SSID, which is already set in the router, and I didn't change it. Oh, it's chosen channel 6 today. It was channel 1 yesterday. Interesting. Probably has an auto channel select as well. And on the WAN side, the wide area network is connected to my house Wi-Fi. It's got that IP address from my normal internet access point router. Somewhere, DNS server, that's correct. That's the one I actually have running. It's a Pi-hole. But anyway, there was a little problem when I changed the IP address range. Maybe I can show you if we look in network, because you will probably have to do this. Oh, actually, that's not there. That's the WAN. Oh, here's the LAN side. You can just type in a new address range. As I said, when it comes out of the box, there's a 0, 0.1. I changed it to 1.1, and then it just reboots and updates. The problem is that it got the DNS server address wrong automatically. It has its own DNS server, a DHCP server inside the little router, so that clients that connect to it are given IP addresses in this range from ending in 100 to 199. When I connect up my little Raspberry Pi board, it'll get 0.101 because it's the first thing that's going to connect to it, probably. The DNS server address set to 0.0.0.0, and this means it gets it from somewhere else and puts out the right one. Yesterday, when I did this change of IP address range, it actually managed to keep the old one and not put in a new one, and then there was suddenly no internet connection through it, and I had to go looking around to find out why not. So all zeros is fine, or an IP address that you know is correct, but when it's the wrong one, it's not correct. You should change it. What else was I saying? you can update the firmware. If we go to System Tools and Firmware Upgrade, here you can download the file from their website, TP-Link. Make sure you go to the right country for your particular device where you bought it, because different countries have different hardware versions. This is V4, the one that seems to be used in Europe. And you make sure you get the right firmware. If you download the US firmware and try to install it in here, I don't know what will happen. But also the regulatory requirements for power that's transmitted in the Wi-Fi band are different. I think in Europe it's 20 or 22 dBm limit, and in the US it's something like 30 or 31 dBm, which is 10 times more power. It's 1 watt. So that would not be legal in Europe. So you have to make sure you get the right firmware version for the right hardware version in the country where you are. Complicated, isn't it? Anyway, so that's the little router that's running, and that should be enough. We need to make a note of the SSID, the name of the router, because we're going to put that in the Raspberry Pi Imager program, so the Raspberry Pi can connect automatically to it. You also need to know the password, which is actually printed on the back of the router itself. I think it's 8 digits. It's a string of numbers like a phone number, which I'm not going to show you, but it's actually visible if you look in the Wi-Fi security settings or wireless security. It actually shows it to you plain, so you can copy paste it if you want. So the place to put it is into the Raspberry Pi Imager, which is what's going to write the SD card for the Raspberry Pi. I've already chosen which software, which OS version I want, which is the it's under Other. When you look through the list of available softwares on this Imager, it's not on the front page. You have to click Raspberry Pi Firmware Other to get older versions. And what I wanted is the 32-bit version, which is headless, has no display output, no graphical GUI interface. I've forgotten what the word is they used, but it's the headless one anyway. And 32-bit is fine for this application. And what I've said was I want to write it to an SD card, which you can choose, and you choose the Raspberry Pi version you've got, which in my case was a 02W. So you choose those things and click yes, I want to write that, and then it asks, do you want to customize the OS? And the answer is yes. You click Edit Settings. I've already got this window open because I don't trust it not to forget the settings already made, which is here. It looks like this. And in here, this is where you can give your Raspberry Pi a host name. So I've called it Raspi-15. I give a different name to each one because the problem is if you give it the same name but it's got a different hardware or the other way around, then when you try to SSH into it you get an error because the keys don't match with encryption, and it's a bit messy fixing that, so it's easier just to give a fresh new name each time you install it. You can give your user a username. So that's what's used to log into the Raspberry Pi as a user, and I'm going to do it by SSH. So this is the username that I use. Password is behind there. And then you have to check the box, say I want to configure wireless LAN. You put in the wireless LAN SSID for the little router, which is what we saw on this page here somewhere. And you put in the password. That's a string of numbers that's printed on the little router box, which I'm not going to show you. And choose the wireless LAN country for regulatory reasons with power limits, and time zone's not so important. Keyboard layout's important sometimes because I oscillate between different countries, and sometimes Z's and Y's get mixed up, especially when you're typing blind passwords and things. So those are a good idea to set up. You have to make sure you get this right, otherwise it won't connect to the router, and then when you try to connect via the network connection through the router, it won't work. Services enable SSH because we're going to SSH into it. What are the options? I eject when finished. Okay, that's enough. So let's save that. And what I'm going to do I want to apply these settings? Yes. And it's going to delete everything. Yes, that's always a good idea. And it wants a password for this computer, which is, what is it? You have to store a lot of passwords in your head because, of course, they should all be different. Don't reuse passwords. So it's now going to write that image to the Raspberry Pi. And this could, the SD card, this could take quite a long time, maybe 5 minutes or even longer. So what I'm going to do is pause the video and come back when that is finished writing. And you can now see that on the little router control panel, if you look at DHCP, the clients list, when you hit the refresh button, you see there are now 2 clients connected to that router. The first one is this laptop I'm using, which gets the first IP address in the range. And as I guessed, the next one is 101, which has been assigned to the Raspberry Pi with that host name. While I was looking, I thought I'd just show you the software that I downloaded. This is the one. It's called OS Lite 32-bit. So it's got no desktop environment. It's headless. It's now cached on my computer. It wasn't before, which is why it was taking some time to download. Next time it'll be much faster to write the card. I let it verify as well, just to make sure that it's written properly, and that took a total of 6 minutes, which is longer than it took me to make a cup of coffee. Anyway, what do we do next? So we've got that. The next thing to do is to go to the command line, and you can see I was getting impatient because after you put the SD card into the Raspberry Pi and apply power, it has to install itself before it can actually run the OS. And you notice a little green light on the Raspberry Pi flickers for quite some time. It took nearly 5 minutes. So when I tried to SSH into it, I thought it had finished, and it hadn't. So I tried pinging it, and you can see that I caught the instant from when it was unreachable to when it suddenly started responding to pings. Look how the time drops once it learns the route. So when it's pingable like this, you get a response, and you know it's working, so you can start talking to it. So now I'm going to SSH into it. So it's the username you selected for your user, and that's the IP address of the Raspberry Pi you get from the router. Hopefully, yes, it's connected, and it's asking if I trust this key, because it's the first time that this machine is connected to that little Raspberry Pi board, so you have to type yes, Y-E-S, because I trust it. This is what happens if you change the host name or anything else of the hardware. Then it'll come up with a big error saying it looks like a man-in-the-middle attack, because the key's wrong, and you have to go and delete it out of a host file. So it's easier just to give it a new name, which is what I did. Put in the password. And this is the password you set for the user in the Raspberry Pi Imager program, and there it is. Let's run HTOP. It's already installed in this OS, and you can see how much memory it's using. It's using 53 megabytes of RAM to run the OS at the moment. It's not doing very much. Control-C to exit. And the next thing I have to do is sudo apt update, and then full upgrade, which you can see in the notes here. Let's move this up a bit. So you need to do that. That's going to take another 5 or 10 minutes, and then I would recommend doing this, the RPI update, which updates the firmware in the Raspberry Pi, the bootloader itself, just to make sure it's the latest version. So I'm going to go put in these 3 commands. It'll take a while, so I'll pause the video again, and then I'll come back and we'll install the MessChat software. I'll show you how this starts anyway, so you don't need a password. Sudo apt update. Normally Ubuntu would ask you for a password, but here you just go straight in as root with root access, and it starts updating the package list. This is going to take a while, so let's stop this video. So the update's now completed, and these are the 3 commands I used, and I rebooted afterwards. You have to do full upgrade, not just upgrade, otherwise it leaves off a few packages, which I forgot. So just use these commands as they are here, and then reboot. With the Raspberry Pi Zero, or any Raspberry Pi OS, you have to do sudo reboot, not just reboot, as you would on Ubuntu. So that looks like that at the bottom of the screen down here. And if you scroll back through, you see all of the updating that it did. Quite a lot of stuff, and it took some amount of time. Anyway, that's finished now. So the thing to do now, don't reboot it, is to make sure it's still working. By the way, it's worth checking when you're using Wi-Fi to connect into a device like this that the desktop you're using, or whatever you're using, is still connected to the right node, the right Wi-Fi access point, because sometimes some operating systems automatically reconnect to the best one for you, which may not be the one that your other device is on, but they don't know that. So watch out for that. Make sure you're connected to the right one, because sometimes you just can't SSH and then you realize you're on the wrong network. So that's the right one. So what I'm going to do now is install the MessChat software, which I've done several times before in these videos. So if you've seen it before, you can skip it. How do we do it? We've SSH'd in, so I've done an update, upgrade, done all that. We have to install Git to download the software. So let's do that, because it's not installed by default on Raspberry Pi OS. Yes. These things, most of them don't take very long, so we can not have to pause the video. whilst it's doing that, let's copy paste the next one, which is to install pip, the package manager for Python, because of course this software is written in Python and Python 3 is the current version that's installed on these machines. So let's do this, install pip, which is not very big, so it shouldn't take too long. Yes, and whilst that's doing, let's copy this. You can just double click in Google Notes and it highlights the whole command, not just the whole line. And because I'm doing it on Ubuntu 22 and not Linux Mint, it doesn't put an extra space on the end, thank goodness. Still don't know why that might be. So I've copied that and I'm going to paste it into here. This is where people have music on their videos, which I don't have. Anyway, it's almost done. You only have to do this once, of course. There we go. So we're going to get the key for the repository. Got it. This is the version number for Node.js, which is very fast to put in. Boom, that's done. Then we're going to do this. Which is also very fast. Put that into a file like that. And then we're going to update the repository list, because those new repositories have been added for the MeshChat software and for Node. Shouldn't take too long. Okay, that's done. No nasty errors. Good. Now we're going to install Node.js. So that's the JavaScript runtime which will run without a web browser, which is how this software works, how you access the API. Hopefully won't take too long. And while that's doing, let's have a look, see what comes next. Oh, this is where we actually copy the software from GitHub for MeshChat. So that will be the next command. Sure, this went far. Oh yeah, last time I did this was on a laptop running Ubuntu 22, and of course that's a much faster machine than the Raspberry Pi Zero, so things are going to take a lot longer here. Okay, that's done. So this is going to download MeshChat program, which is not very big, so it'll be pretty quick. And as I said before, I think it downloads all the versions and then it only installs the most recent one unless you tell it otherwise. It pulls it out of the file somehow. So we change the directory that's been created by that git command, which is there. Let's make sure there's something in there. Oh yes, software's arrived, good. So then we do this, which is going to look in that text file and install the libraries required by MeshChat. Don't worry about this break system packages at the end. All that means is it gives it permission to do what it needs to do. Nothing's going to get broken, probably. Famous last words. Anyway, it's downloading what it needs and installing it. That looks good. What's the next command? To install the Node package manager without the developer options. So that'll be next. You see how much time you can spend doing this with all these updates and reboots and installing software on a very slow computer. It takes a while, but once it's done, and hopefully it'll work straight away. You can see all the amazing work that's gone into this. It's really clever stuff with cryptography and everything. These warnings are not fatal, they're just information, let's say. So it's installed all of that, good. So now we do the npm install, which will again take some time. Oh, this is the one where you just see a little thing going around in the corner here and no messages popping up in the terminal. So it'll take a while on this slow machine. Oh yes, on the Pi Zero there's a problem with limited space in RAM, and so you have to do this, and if you don't do it, it gives an error, I've noticed. So we need to run that little command to avoid errors on the next part of the install. So I did record, pause the video, and now it's finished. So the next command is this one, about space saving in RAM. And then we need to find the next command, which is this one. Keep going to the wrong place, don't I? So that's installing the front end using the Node Package Manager. Hopefully that will run. And the next thing is to run it. Oh my goodness. Actually, during this procedure, it went wrong. And when things go wrong, I don't even try to fix them because it just got more and more messy. So I had to restart right from the beginning. I'm being honest and telling you it went wrong. And I think maybe the problem was because I didn't do a reboot in between. I'm looking at the wrong notes. Up here, after the full upgrade, I didn't do a reboot and I went straight into this. Maybe that was the problem, I'm not sure. So I had to start from the beginning again and did the reboot. And now it's run through without any errors, because last time the error happened when I did this command. So this time it was fine. And as you can see, we have gone through all of these, so now it's time to run it. Let's copy it from the right notes. Okay, Control C. Is that finished? Not quite. No errors so far, which is always good. I'm not sure if I made a mistake during the first install or whether it was the lack of reboot. I also unplugged the rack R node from the Raspberry Pi board, just in case that was causing some problem. I doubt it, but it's a USB device. It doesn't need to be there. So I unplugged it. So that's worked. So now we can just run it. So Control-Shift-V to run the program. Let's see if it works. Mesh chat. Taking a few seconds to start. There was no config file, so it created one. That looks good. And it's running. And it's being served up locally on the local host with port 8000. Also, I would be able to access it via another machine on the same network. Remember, that's the network that's running on this little router Wi-Fi hotspot. So if I put in the address of the Raspberry Pi, I'd be able to see it. What I'm going to do is stop this now by pressing Control-C. If you type IPA, you can see the network set up, and the IP address of this little machine ends in .101 as we expected. So if you put this address into a web browser on another machine with :8000 for port 8000, then it would actually connect. I'm feeling brave, so let's have a go. Why not? Let's just check we're in the same network. Yes, we are. That's the right access point. So Control-T, Control-V, and no, that's not what I want. I'll just type it in. It's quicker. 92.168.1.101:8000. And of course, before having a go at that, you have to make sure that the program that's going to serve up the web page is actually running. So let's run it again. And hopefully it will be visible on the web browser. So find a web browser, put in the IP address, press enter, and see what happens. It's not secure because it's not encrypted, because I'm not using HTTPS. And I think on my own network it's okay to do that. And look at that, sure enough, it's loaded up that page, which is being served from the program that's running on the Raspberry Pi board. And it's working fine. There's no R node interface plugged in yet. It's just got its default interface, which we can disable because we don't need it. So I'll disable that. So that worked. And if I go back here, press Control-C, I can exit that. And what I want to do now is make it so that this will start when I reboot the Raspberry Pi, because I don't want to have to manually SSH in and type in this command every time. So how do we do that? Let's go back and look at my notes here. And what we need to do is to edit this file, first create it because it doesn't exist yet, and edit it and put 3 statements into it. So I'm going to do that now. Copy that and sudo nano, yeah, that's the file name. So there it is, empty file. And then I'm going to put in these 3 commands. Now you have to be careful with the username because you need to use your username and not my username. So that's quite important. These are the 3 commands. I'll put all this in the description so you can copy paste it, but in 4 places you have to have the correct username. 1, 2, 3, 4, those 4 places. So Control C to copy that, Control Shift V to paste into there, and Control X to exit. Do you want to save? Yes. Where? Here. Enter. So that's saved. And what we need to do is to start and enable the Mesh Chat daemon. In fact, what we can do is have a look at it first. That service, the status of it is like that. Not yet enabled because I haven't enabled it. So what I'm going to do first is start it. So that started up the program, but you can see we've got the command prompt back. So we're not getting the error outputs or the log output to the terminal, but we've got the command prompt back again. I'm going to enable it. So when you enable it, that means it will start on boot. Put that in there, and hopefully it will manage to do it. Yes, it's done it. So it's created a symlink for that service to run on boot up. And we can look at the status again. Status. And you see this time it says enabled instead of disabled. So it means it will start on boot. Control C to exit that. So I think that's it. That's it. It's working so far. What I need to do next, of course, is to plug in an R node, and normally I would flash that on a separate computer rather than trying to do it on this little Raspberry Pi board headless. It's easier just to do it with the browser flasher and then put everything into the box and we're ready to go. So I think I will show you what it looks like when it's assembled in the box. So here we go. And here it is, the finished product after all that installing and drilling holes. I even managed to drill a hole this morning in the wrong end of the box. You can't see it because it's black on black, because I filed a little slot here for these 2 cables to come through, and then I didn't pay attention, drilled the hole in there instead of in there for the antenna. It's one of those days, but it works now and everything's put together, and you can see that that tiny router just about fits inside the box. Stands up a bit proud, which doesn't matter because the lid has a recess in it and it fits on like that. And then you put the screws in and it's all screwed together and waterproof because the lid even has a white plastic rubbery seal in it. So that's it. There's the finished node. Everything's working, and what I'm going to do is connect it up and see if it receives any signals, and that will be interesting. So let's try that. Here's the user interface viewed in the web browser on a laptop, and you can see that the device is working. Version 1.20 is the latest version, and what I did before I switched over to this was I actually installed an interface, because you've seen me do it several times before. So I did add interface, and then I chose an R node interface as the type, gave it a name rack because it told me it's a rack module and not a Heltec. You don't need any unique names here, and they're not published anyway or sent over the air interface visibly as far as I can see for end users. It's just for my information. So I've added in the standard frequencies. That's the frequency that's used for Meshtastic in the ISM band, 868 megahertz, and bandwidth, spreading factor, encoding rate that we use, and it seems to be working. I've connected the little 50 ohm load to the antenna port, so you can see the noise floor is very low, minus 114, minus 115 dBm, which is what we're coming to expect from these when they have just a load connected to the input. We'll radiate some very weak signals, of course, and so I can use it against my other nodes to test that it works. And I've given it a name,
Raspberry minus 15, because that's the host name on the Raspberry Pi controlling computer inside the box. And I've set to announce every 15 minutes, so it propagates through the network. Not that there are many nodes around at the moment, but let's have a look. Announces, oh look at that, it's started collecting them already. This is about 3 or 4 meters away on my balcony, and it's connected to the large white antenna I use sometimes through a filter, the new filter I got yesterday, and obviously it's found that straight away. If I ping it, and I'm sure it will respond with a ping, and you'll see, there we are, there's one hop. That means the only hop from this device I just put together to the one out on the balcony. Obviously that signal quality is 100%, and at 8.5 dB signal noise ratio, which is very nice. Signal level is minus 74 dBm, which is quite a small signal. The ones I'm getting from a few kilometers away on the antenna are minus 100, so that's because there's only a 50 ohm load connected as an antenna here. So of course the signal is not radiating very well, but it's good enough for testing. And these two nodes belong to a friend a few kilometers away, and they've been repeated via the node on the balcony, which is set up as a transport node, which is what I'm going to do with this one here as well, because in the end this will replace the one on the balcony, and the one on the balcony is the one I'll go out when I go out for walks. So it's repeated these and made them visible, and you can see they're 2 hops away. This 8 dB signal noise ratio refers to the last hop, the one closest to me, which is a distance of 3 meters, and you can't identify what the other hop parameters are. That's the whole idea of the system. You don't know what's in between. So it's also 2 hops, and you see it's the same SNR because it's coming via the same node. So what I'm going to do now is in the interfaces, there's a new setting. In this version 1.20, you go to Edit, and then you go down here to Optional Interface Settings, which is currently not set. And what I'm going to do is set it to Gateway, which means that it will act as a gateway between being on the balcony and to other nodes indoors here, which is what I want. So I'm going to save. As a warning, you've got to restart for that to take effect. But before I do that, I'm also going to go into the settings here and enable transport mode. So it's going to enable traffic for peers to pass through it. I'm also going to go down here and enable a local propagation node so that other nodes can use it, my ones here. This is all very experimental for me, trying these things out, but if I do this, it works. It actually propagates messages through, as you saw with those other nodes that were picked up when we look on here. And the announces, these have been propagated from a node on my balcony, and in fact it's this one that's doing it. So that should work. And you need to restart the program, and the simplest way, you can actually just go on the command line and restart the mesh chat. What I do is just reboot the whole machine, and then it's definitely clean and restarted. And the way I do that is just to type sudo reboot, press enter, and it reboots. And takes it a few seconds to do that, of course. While I'm at it, let's have a look with HTOP at the memory usage. And before I had mesh chat running, this was I think about 50 megabytes in an earlier part of this video. Now it's 80 megabytes. So you can see how much memory is being used. Maybe it's between 20 and 30 megabytes of RAM used to run mesh chat. And somewhere in here you'll see it's running. There it is, that one. So it all seems to be working nicely. So I think this is a good place to stop. And I'll say thank you for watching. I hope it's useful. You managed to get something set up, and I hope to see your node on the air sometime. Remember to like and subscribe if you would like to, and see you in the next video.